Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on reservoir simulation using tNavigator. And it's still about the case for drilling a new well. In previous videos, first I began with drilling a new producer, vertical producer. And in the next video, just previous video, one video before this series, before this case, there is a case for creating a new injector close to this P1 producer. So if I move the time slider, so that's my new injector. Okay. And as the time continues, water injection continues, all right. And we see water cut increase in this well. But the water cut increase hasn't been exceeding the water cut limit. The water cut limit is 40%. And if that limit is exceeded, the control that we impose is the simulator will shut in the well. Okay, that's the limit. So if we check this one, P1 producer, and go to economic limit, this one, it's 40%. Okay, the water cut 40%. Okay, so if the water cut here is greater than 40%, this well will be shut in. All right, but currently with our model, the water cut, the last water cut is still 32%. Okay, of course I can continue just do the simulation more than more than 2013, but instead of doing that, I will just add even new injector closer to this one. Okay, and if we add new well, we still have this control, these settings. So you click this one, well creation settings. Okay, we can use this one again, single injector common settings. So each time we add well, this setting will be applied. Single injector common settings. But we can use this also, single well detailed dialog. So I can select this one and then move the time step. Let's say we will add time step 13 or maybe 15, and I will add new injector here, maybe add well. All right, so no group, this is the name of our well. Let's say we will call it injector 2, like this one. Okay, by default, all the vertical layers will be opened. Here, the symbol of our well. Yeah, I prefer opening all the vertical sections. Again, the injectivity index, or in this case, PI, still 1. And then diameter 0.16 meter skin if you want. It can increase the skin a little bit, 1.5. Okay, and then maybe 1.75. It's just for illustration. Okay. Again, it's just for illustration. And it's still vertical well, it's okay. Control, I will change it to injection well. Okay, injection fluid water, and the bottom hole injection pressure 450 bars. And I will cap the injection rate maximum to be, let's say, 500. No economic limit setting, it's okay. So click add well. The well disappears and it will appear in the next time step there. Okay, so in time step 15, it's just setting up the well, and it will come up at the next time step there. Okay, so I will go back to the original time step 0, and then let's run the simulation. Hopefully the new injector I2 will increase the water cut at P1 in such a way that the limit will be exceeded and the P1 will be shut in. Okay, so you see the change in mobile oil, and we can also show the saturation of oil. Okay, let's wait. Now our new injector. Okay, we also can see the 3D show grid, not transparent. Now you see the I2, it's very close to P1, right? You can also like this one. Okay, 85% progress. Okay, it's now what 100%, and I'm sure water of I2 has been broken through this P1. All right. Okay, and then let's just see the streamlines. Okay. The streamline, yeah, there. So let me try again. I want to see the streamline. So there's a problem there. Okay, there is an issue for the streamline, but that's okay. The main thing I want to show you is the graph. But yeah, this is the streamline. So you see the streamline has been created. So now it's interesting. So P1 has been connected with with this injector and I2. And this is for the 3D streamlines. Okay. Okay. So let's check the graph. First, I want to show this one. All right. Now, you see, the well at this point is shut in. Okay, this one. First, it produces at rate of 100 and then it declines due to water cut increase. But suddenly the production stops. Why? We will answer that later, but let's check the pressure. All right, so here the pressure declines because of only production, and then the pressure increase, okay, because of the presence of injection. But then the bottom hole pressure goes to 0. It means that the well is shut in, all right? And then the pressure on equivalent radius increases because, again, there is no production, so the average pressure increases. So why does this happen? Let's check the analytics. You see, now the water cut limit, this one, the water cut limit has been exceeded. So if we check at table, my water cut limit is 40% or 0.4. It means if my actual water cut is greater than 40% or greater than 0.4, I will shut my well in. I will shut my well. Okay, so that's the rule that I impose. And you see, at June 2012, the water cut is greater than 0.4, and that's why the software shuts the well in. And that's the end of this simulation. Okay, and let's go back to rates. Yeah. So you see, I put limit for the injection rate. All right. And the injection decreases. So that's why at the end of the time step, we see no streamline. Okay, because the rate goes to 0 for this one and for this one. And we can check based on the pressure. So you see, the difference is very, very small between the bottom hole injection pressure. Okay, the maximum to be 450 and the average or the pressure on equivalent radius. This is for I2. So the difference is very, very, very small between the maximum injection pressure 450 and the pressure on equivalent radius. So because the difference is very, very small and the difference is the driving force for the injection, that's why the injection goes to 0 and the injector practically doesn't inject. Okay, and we can also check the pressure at the reservoir or the field here, and you can see the value here at this section. All right, and yeah, this is also for the injector, this one E11-1. So because the difference between pressure on equivalent radius, which indicate the average reservoir pressure surrounding the injector, and the bottom hole injection pressure, because they are very, very close, and they are the difference is the driving force. So that's why the injection rate goes to 0. Okay. Here, it's not 0 actually. It's just very, very small. And that's why again the streamline disappear. Okay, so this is the well is still producing, but then the well shut in and the streamline no longer connected to the producer as the time continues. You see, right? There is no connection because this well is shut in right now. And that's the story of our third case. And in the next case, in the next video, I will try to add new well, but now it's horizontal production well. Okay, so that's all. I hope you enjoyed the video. I hope this video is useful. Thank you so much for watching and see you again in the next tNavigator videos. Thank you.